I'm just going to show a couple more examples of finding all the roots now. So this will be just two more examples, just to give you a little bit more practice. So again, I would encourage you to try to go through them by yourself. Okay, so pause, try to go through this one, and then hit play and see what I do. So try to do that for both of them to give you some really good practice. So the first thing we're always going to do is we're always going to graph to try to see if we can just see some roots that are popping out for us. So x to the fourth minus 8x cubed plus 17x squared minus 8x plus 16. Okay, let's zoom and make sure we're seeing everything. Okay, and then check our window. Okay, so I really don't need to see that many. I was just mainly looking to see if it was going to show me some other x values. Okay, but it's keeping my x values the same, so we'll just look -5 to 5 because I'm only concerned with where it's crossing 0, and I only see this one spot right here. So it's bouncing, which is a hint to me that that is possibly a double or quadruple root. Okay, it's going to be a root that has an even power to it if it is in fact bouncing right there. So when they bounce, that's at least a double root. So that's a possibility. So in order to check to see if that's really happening, first I want to check my table. Okay, 4, that's where I saw it. So now I need to see if it's a single root or a double root or a triple root or a quadruple root. In order to do that, we're just going to see how many times I can divide that out. So this is the factor I'm looking at. Since I'm having a 0 at 4, that means x minus 4 should be a factor. So I'm going to divide it out. I'm going to do this one with synthetic division, just to give you another example of synthetic division. So I'm taking out 4. Okay, that's the root. You always put the actual root here, not what's inside there. My coefficients are going to be 1, -8, 17, -8, and 16. Okay, you drop the first one down, you multiply these. 4 times 1 is 4. Add these up, you get -4. Multiply again, you get -16. Add, you get 1. Multiply, you get 4. Add, you get -4. Multiply, you get -16. Add, you get 0. Okay, so it's at least in there once. Okay, because I got remainder 0. Let's see if I can take it out again. So drop it down, multiply, you get 4, add, you get 0, multiply, you get 0, add, you get 1, multiply, you get 4, add, you get 0. So that means it's at least a double root. Okay, so let's see if it goes in there again. Drop the 1, multiply, you get 4, add, you get 4, multiply, you get 16, add, you get 17. Okay, that's my remainder, so it doesn't go in again. So I don't want any of this stuff. I want to stop back up here where I knew it came out. So this leaves the coefficient of 1 in front of my x squared. I have no x's, and I have one constant. So this is what's left over after I took out, that's not a minus sign, after I took out x minus 4 2 times. So to get my other two roots, I'm going to set this equal to 0 and solve it. So I can just subtract 1. X squared equals -1. I can square root. Okay, so I get x squared equals plus or minus I. So my 4 roots would be 4, and that counts for 2 of them. That's a double root. So 4, 4, I, and -I. Those are my 4 roots, which is how many I should have since I've got a 4th degree polynomial. Let's get one more. This one's going to have 5 roots. So again, we're going to graph it to start off. So at this point, you could pause, try to work through it yourself. It's going to be a long one. 56x to the 5th plus 334x x to the fourth minus 149 x to the third minus 140 x squared plus 86 x minus 12. Let me just check, make sure I got it all in there right. Okay, let's check out my graph. Ooh, there's lots of stuff going on here. 1, 2, 3. Looks like 3 roots in there. Let's get rid of this stuff. So cut down my x's here. Let's space them out a little bit. I think if I just go up to 5, that should be good. Okay, let's cut down my y's. Yep, it looks like 1, 2, 3 roots that I've got. Okay, I've got one that's between 0 and negative 1. 0 to negative 1. I've got one that's between 0 and 1. I've got one that's between negative 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Between negative 6 and negative 7. So let's look at my possible rational zeros to see if any of these are going to turn out to be rational. And that'll help me figure out what my table settings should be. So possible numerators are going to be factors of 12. 1, 2, 3, 4, 6, 12. Possible denominators are going to be factors of 56. That's 1, 2, 3. Does 3 go in there? No, it doesn't. Okay, because 5 plus 6 is 11. That's not divisible by 3. 4. 4 goes in there. 5 does not. 6. Would 6 go in there? No, it would not. 7. 7 will go in there with 8, because 7 times 8 is 56. What do I multiply by 4 to get 56? That's going to be 14. 2 times 28 gives me 56, and 1 times 56 gets me 56. So these are all my possible denominators. So I just want to look for ones that are between 0 and negative 1 first. So let's give us a little more room here. So I could have negative 1/2. Okay, if I take this, I could have negative 1/4, 1/7, 1/8, 1/14, 1/28, 1/56. Okay, so that's a lot of them. Okay, I could also have 2/7, 2/8, which would be 1/4, which I already covered, 2/14, which is 1/7, 2/28, okay, we already covered all those. I could do 3/4. Okay, I could have 3/7. Okay, so that one's going to be pretty hard to find. So there's not going to be a whole lot of them that are going to be up in this range. So maybe we'll start with that, and that could cut down on the numbers that we have in here. So let's find all the ones that are between negative 6 and negative 7. So I'm going to have a bigger number on top than what's on bottom. So 2 is only bigger than 1, so that's not going to help me. 3 is bigger than 2, but that's not going to get me big enough here. 4 is bigger than 2, that's only 2. 6 is bigger than 2, that's 3. 12 is bigger than 2, and that would give me negative 6, so maybe that's 1. Okay, I could do, let's see, what else would be in there? Is that the only one? Well, 12 over 2 is 6, 12 over 4 is not in there, so it must be that one. Let's check our table and see if it's negative 6. It doesn't look like it is.
Brandon, stop it. Nick says too.
So let's check my table here. Yep, when I'm at -6, I'm not quite there. Okay, so that must not be a rational one. Let's just try some of these ones between 0 and 1. So let's go to my table settings. We'll start at -1. Okay, and let's see, if we do 56th, that'll cover eighths, fourths, and halves. So let's do that. What do I find a 0? Oh, there's one. -0.75, I know that one. That's -3/4. Keep looking here. Oh, there's another one. 0.28571. Okay, and that's a little bit bigger than a fourth and less than a third. So I'm thinking it might be a seventh because I'm getting a weird decimal. So let's try some of our sevenths here. 2/7 and 3/7. Let's see what those are. There's 2/7. So positive 2/7 is another one. So we found two there. Let's see. So I'm having troubles finding this one that's between right there. Let's go to our table and set that one up. So we'll start at -7. Have the same changes. See if we can't find this one. Nope, nope, it's not there. So it's in between these. So maybe. Okay, so we're still looking here. Okay, and it's between these numbers. And I'm not getting it when I have a change by 56. So it must be one of these changes that's by 7. So let's try and see if we can find that one. So change our table. Okay, to start. Yeah, I can start right there. -6.321. Then we want to go up by a seventh. Or a 28th. We'll do 28th because that'll cover 14ths and 7ths. Oops, 28. Or actually, we do need to start at -6, so we start at the whole number. Oops, -6. Going up by 1/28. I want to go this way. I want to head towards -7. Okay, so it's right there, so I'm not finding it. So it must be a weird one that I don't have listed here. So we'll divide out the ones we've got. Okay, we divide these out and see what happens after that. So I'm going to divide this thing. I'll just move it down here. Okay, I'm going to be dividing out these two. So we can use synthetic or long division. You could do two separate ones, or you could do one if you multiply them together. If I multiply these together, I'm going to get some ugly fractions. So I'm actually use synthetic here, just because it's a little bit easier. So I'm going to have 56, 334, -149, -140, 86, -12, I'm going to be dividing out -3/4 first. Okay. So we'll take out -3/4. It's going to drop the 56 down. 56 times -3/4, and we can use our calculator for this. It's -42, so I put that here. Add these up. That's going to give me 292. Multiply these. -219. Okay, so -219 will go in here. Okay, add these, which is going to give us -816. 368, multiply that. Okay, so negative is positive, so positive 276. Add these up, that's going to give me 136. Multiply that. Okay, positive times negative, or positive times negative is going to be negative, so -102. Add these up. $16, so that's negative, times 3/4 is 12. Add these, I get 0. So that one did come out all right. From this, I should be able to take the next one out, which is +2/7. It was a positive, right? I'm pretty sure it was positive. Let's check our table. Yeah, there it is. Positive. Okay. So I take 2/7 out. So 56. Let's see, the 7th will turn this to an 8. 8 times 2 is 16. Add these up, I get 308. Divided by 7 times 2. Oops. 308 divided by 7 times 2 is 88. Add these, and get 0, and 36 gives me 28. Divided by 7 will be 40, times 2 is 80. Subtract these, I get 6 and 5. 2/7 of that is going to end up being 16. Okay, let's divide by 7 gives me 8 times 2 is 16, so I get 0. So both those came out pretty well. Now I've got this new one, 56. Let's see, this would be constant x, x squared, x cubed. It's 308 x squared minus 280x plus 56. And that's not really helping me because actually I'm getting more factors on the top. So let's just look at my table again and make sure I didn't miss something. First, let's look at our graph here. Okay, so it's going up. It's coming back down. And then I'm not seeing anything in here. This is where it should be crossing. I'm not seeing any of that. So it must go up and down quickly somewhere in that area. Because when I zoom to the standard again, okay, this is where it was coming up, coming down. Here it's crossing, But I know that my end behavior is it's going to be going up. So it's got to be crossing more than once somewhere in there. So let's check our table again. Start at 0. Go up by the 56 again. See if we can't find another one. So there's the one I took out. There's another one. 1/2. So I can take 1/2 out. I just didn't go far enough on my graph. So I'm going to take 1/2 out of this. Drop that down. Half of 56 is 28. Add these, I get 336. Half of that is 168. Take away 280. It's negative 112. Half of that is 56. Take away 56 and we get 0. Good. So I got 56x squared plus 336x minus 112. If I set this equals 0, I'll get my other two roots. I should be able to factor something out. Okay, at least a 2 because these are all even. Could I take a 4 out? I don't think so. Let's take a 2 out and see what happens. So I'm going to divide everything by 2. And still take another 2 out. This turns into 28. Still take another 2 out. Uh, 14. Now I can take a 7 out. There we go. Now this is going to be a lot easier to simplify here. So we can complete the square, we can use quadratic. I'll use quadratic, just I don't think I've done a lot of examples with quadratic. So negative b plus or minus square root b squared minus 4 times a times c over 2a. So 4 times 2 is 8, negative and negative is positive. So I have 36 plus 8, which is 40. Over 2, 40 breaks down into 8 and 5. 8 is 2, 2, 2, and 5. So a pair of 2's comes out. We've got negative 6 plus or minus 2 square root of 10. Over 2. And I can reduce all these by 2, so I get negative 3 plus square root of 10, negative 3 minus the square root of 10, and the other ones that I divided out, which were 1/2, 2/7, and negative 3/4. These are all 5 of my roots. So, and that's kind of the process you have to go through. You know, I'm using end behavior to determine if it's, you know, bouncing multiple times in my graph. You know, when I looked here, I can see it's going. My end behavior, since it's odd, I just want to go through that again. I've got odd power, positive coefficient, so I know my end behavior is going to be, it's going to go down that way and up this way. But if I look at what I've got on my graph, I can see it's coming. Okay, it must be coming from the bottom, crossing here. It's coming down, it's coming up. But then when I zoomed and looked at the whole thing, it wasn't really coming up again until over here. So, I mean, it was just kind of a guess that was bouncing, and I had to just look at my table a little bit more. The big thing that's going to help you is setting your table up to see every possible x-intercept. So that's using your P's and Q's to try to cover all those. Okay, and this is one of the hardest, this is probably the hardest problem that I'd put on there. The only thing that would make it more difficult is, if you had a negative inside your square root, and all that's going to do is add an I term in there. So if you could do something like this, then you should feel comfortable with your ability level.